So can you see my screen, the welcoming screen, the presentation?
Yes, Mario.
Okay. So we can start. Hello, everyone. Hello from Mannheim, Germany. My name is Marius Berg from Cognitive UX, who is hosting this event. And I would like to welcome you all to the second Multiplier event of the CREAMS project that is being held in Mannheim, Germany. So I will make a quick welcoming note and give you information about the agenda. So this Multiplier event relates to the European funded research project CREAMS, which is co-funded by the Erasmus Plus program of the European Union and the State Scholarships Foundation in Greece, IKI. And today we're going to dedicate the whole day to inform the participants about the outcomes of the project so far, the project results, and this serves as both a dissemination purpose, but as well as educational purpose. So CREAMS is, as I mentioned, a research project that aims to analyze, design, implement, and evaluate a platform aiming to scaffold creativity of art students through a framework, a tool chain, an educational material on how students can create their own virtual exhibitions. As I mentioned, this is a hybrid event. We will have later on in-person participants at the University of Mannheim, at the Mannheim Baroque Palace, the University Gate, and we have in this session, which is a hybrid session, but mostly online, we have online participants to inform the audience about the outcomes of the project. The organizers is Cognitive UX GmbH, the leading organization, with all the project partners participating at the University of Patras, the Cyprus University of Technology, the Aristotle University of Thessaloniki, Shenkar Engineering, Design and Art from Israel, and the Norway Institute of Technology, NTNU in Norway. The event today will feature two main sessions. So in this session, we're going to dedicate it to provide information about the project, an overview, the main results, which will include presentations from all the CREAMS partners, making an overview and covering the main outcomes of the project. We'll also have a very interesting talk and invited presentation later on. And in the second session after lunch, we're going to have in-person participants. We're going to dedicate it on a hands-on technology demonstration in which in-person participants at the university will come and interact with all the implemented technologies, which are many as a result of the CREAMS project. So we are going to start in a bit with Professor Dimitrios Gougopoulos, the coordinator of the project from the University of Patras. Then we're going to continue with an invited presentation from Ms. Anna Maria Pietron on promising startup e-story, which focuses on augmented reality touring experiences. And later on, we're going to have a small coffee break and continue with 6 presentations from our project partners, Dr. Stella Silio from the University of Patras, myself on project result 2, Dr. Panagiotis Zafiotis from Aristotle University of Thessaloniki. Then we're going to continue with Ms. Kyriaki Georgiou from the Cyprus University of Technology, following with Dr. Rebecca Vidal from Shenkar. And we're going to conclude the online session with Mr. Martinus Suikerbuik from Norwegian University of Science and Technology, Norway, aiming to give a full overview and all the project results of the CREAMS project so far. Then we're going to have a lunch break. The online session will close, and we're going to continue after lunch with a hands-on technology demonstration. As I mentioned, we're going to set up all the technologies, the Android applications, the mixed reality application, HoloLens, the Digitizer app, the AR app, and the web-based content management system, and the virtual reality exhibition editor and viewer, which will be available for in-person participants to interact with the system. Anyone who, for online participants, we're going to share later on all the links which are accessible online. And we also have system demonstrations and then quick demos for you to have a look to get a feeling about the technology we have implemented so far. So thank you very much again, everyone, for attending. I wish for a fruitful and successful event, and we can proceed with our project coordinator, Professor Dimitrios Gogopoulos, who is going to give an overview of the project and about the CREAMS project. Thank you very much.
Marios, can you give me permission?
Yes, moment.
Yeah.
Okay, it should be fine now.
Yeah, fine.
Okay.
Can you see my screen?
Yes, we can see your screen now.
Okay, fantastic. First of all, I'd like to thank Marios and Cognitive for the organization of the second Multiplier event of CREAMS project. I'm sure for the success of this event, as it happened to all the events organized by our consortium. And also, I'm sure about the possibility of Mannheim University. Well, Dr. Marios told us that CREAMS is an Erasmus Plus funded European project, along with the State Foundation, Scholarship Foundation of Greece, IKI. It's a project with a of 6 partners. University of Patras, Cyprus University of Technology, Cognitive UX, Aristotle University of Thessaloniki, SEMCAT, and NTNU. The project duration is 36 months. It has started on February the 1st of 2022, and it will end at the end of January 2025. Well, about the need. The need is that higher education institutions need platforms in order to operate even in situations like COVID-19. Also, till now, there wasn't a holistic environment that could offer service and functionalities to all the entities that operate in an art school educational environment. Are they lecturers, students, even young researchers? Well, CREAMS comes to cover this gap. The inspiration behind this project is to engage stakeholders of European higher education institutions to elicit requirements related to the creation of virtual exhibitions, design, develop, and evaluate framework and open source tools for the creation of virtual exhibition for art students, implementation and evaluation of educational material for higher education institutions stakeholders, along with training material in the forms of training webinars, LTTAs, and so on, and of course, dissemination and the sustainability of all this. Here you can see the 5 aims behind this project. The first aim concerns the investigation of all the related work in the academic bibliography and in the market, the design and development of an integrated platform that can support virtual exhibitions, indoor and outdoor, from art students under the supervision of their lecturers. The evaluation of all these tools in 3 cycles, giving feedback for the development in 3 rounds, the creation of a repository of course and training material, supporting art lecturers and students that want to use the proposed platform, and of course the dissemination of all this work. Our goal here is to build just a platform, is to build a course that can use our platform as its lab. Our stakeholders, as I have already said, are art lecturers, young students, young art professionals, and software engineers that can incorporate the features of our platform to their digital environment. I speak for software engineers that work in higher education. Some things about the content. The content is the artwork, 2D or 3D, and of course, the exhibition that can be indoor and outdoor. Some attributes about the content. Our content can be text, video, images, objects, animations, geolocation data. We have narrations associated with all this material in the form of video, audio, texts, and of course there are some model-based attributes that are related to personalization and publishing on social media permission. Here you can see the time schedule of our project from the beginning till the end. Now we are at the 25th month of our project. We have ahead of us almost 1 year, and you can see here all the activities we have planned. Now we are a step behind. From the next month, we will start the third cycle of the design, development, and evaluation of our platform, along with the second cycle of the production of training and course material. Well, here you can see the 5 project results. Mainly, they concern conceptual design and specifications, implementation of tools, supporting digitizations of artifacts and creation of virtual exhibitions indoor and outdoor, evaluation, user acceptance issues, the creation of course and training material, and of course webinars for training the trainers and art students. Till now, we have conducted one LTTA event in Greece. The main scope was the training of teachers and to give them information about these platforms and its aspirations. We plan to have our next LTTA in Cyprus in July 2024. It will concern mainly art lecturers, while at the end of our project, we will conduct our final LTTA event in Israel, and it will concern mainly policymakers. Along with LTTAs, we have built webinars. Till now, we have produced a set of webinars about things that concern the virtual exhibition and its design. These 2 webinars concerned mainly teachers and art students. Ahead of us, we have another 2 sets of webinars. The next set is planned for May 2024. Along with Multiplier events, LTTA, we plan technology demonstrations like the one that will take place in Mannheim today, organization of workshops, promotional materials. We have an interactive website which includes all the tools and the knowledge repository, and we plan to get an open source license. Now, what is artwork in our framework? We follow the notion of art sketchbook, and the definition of this notion can be seen in this slide. For us, an artwork is a whole narration, a narration that tells us things about the background, the creator, the methodology. It's actually a whole lesson, let's say, about the specific artwork. We imagine an artwork in CREAMS platform in this way. Here you can see some examples from Aristotle School of Arts. You can see some to specific students. Now, the main functions of our platform is to enable artists to employ 3D digital exhibitions in order to engage audiences, especially young audiences. Also to develop tools that enrich artists' environment in order to present in a new way, in an immersive way, contextual issues, ideas, and personal thoughts about their artworks. Is the creation of multimodal in-depth descriptions in the form of art sketchbooks, and the adaptability of all those modalities employed to the aesthetic and conceptual character of the specific artworks. Where we stand right now, which is our progress? Till now, we have created an environment that permits the creation of online virtual exhibitions with some first personalization capabilities. Also, we have a tool for the digitization of artworks from art students themselves. The 2D version of this app is high fidelity, while the 3D version is low fidelity, and we plan to enhance it in order to permit the digitization of 3D artworks. Also, we have created an augmented reality application that permits the presentation of artworks in outdoor, indoor, and in-home environment. We have enriched our platform with specific interactivity features. We permit the creation of virtual exhibitions, not just the exhibition space, but enriching this space with specific exhibition content created from art students. We have incorporated security functionalities like the role-based access control model and certification mechanisms. We have created the first version of a knowledge repository because, as I have already said, our goal is to build a course, not just a platform. We give multimodal in-depth functionalities. We have a low fidelity version of a mixed reality native application. And also, we have incorporated art teachers, artists, and administration functionalities in our platform. For the last year, we plan to incorporate narrative functionalities into our platform like avatars. Here you can see the followed methodology till now, starting from literature review, investigation of commercial applications and best practices, and arriving at this month where the second formative evaluation of our platform is in progress. Here you can see some work we have published in a journal about the investigation of extended reality technologies that could be incorporated into our platform. And here you can see some results concerning the filtering of literature review findings with expert opinions. In this slide, you can see a basic scenario. We start from the art lecturer that can initiate an exhibition. And after that, he is able to assess the exhibition. Student is responsible for the digitization of his or her artworks and the creation of the actual exhibition, while a visitor can view the exhibition using specific tools and applications from our platform. Which are these applications? They are applications, the mixed reality application, and the functionalities of the web-based platform. Now you can see some mock-ups. Here you can see two mock-ups concerning the initiation of an exhibition by an art teacher. Here you can see two mock-ups concerning the assessment of an exhibition. Some mock-ups about the digitizer application that is used from the art student. And also some screenshots concerning the creation of an exhibition by the student himself. And some other mock-ups. Now you can see some mock-ups about the functionalities given to the visitors to view an exhibition via portal. And some mock-ups with their application. Outdoor, indoor, and in-home. The conceptual design of the current version is illustrated in this slide. You can see that you use 4 databases, one about users, the second one about the exhibitions, the third one about artworks, and the last one is the knowledge repository. With blue color, you can see the back end of our platform. We have functionalities giving art students the ability to build their own exhibitions. We have the art services, along with administration services and security management services. At the front end, there is a number of applications, a mixed reality native application, VR exhibitions, artwork digitizer application, and augmented reality exhibitions. Also, you can see our main users, teachers, artists, students, visitors, and the administration. My colleagues, the other partners, will talk more about the project results. Here I have some slides mentioning quick the main results of each project result. Concerning project result 1, we are at the second version of specifications report. Until now, we have finalized needs validation and verification and readiness metrics of deploying cutting-edge digital technologies. Concerning PR2, we have finalized task 2.1, which is about architecture and structure design. And also, we have developed the second version of a number of tools, along with a specific smartphone application about 2D and 3D visualization. PR2 has finalized the planning report, has conducted the first evaluation, and now the second evaluation of the platform is in progress. PR4 has produced a vast number of course material and training material concerning videos, tutorials, best practices, and a first version of course material. PR5 is responsible for webinars. Till now, as I have already said, we have conducted the first set of webinars. Ahead of us, we have another 2 sets of webinars that will enrich with their recordings our knowledge repository, and they will be the main vehicle of training for students and lecturers. In November, we conducted the first LTTA, and also we have implemented a number of dissemination and exploitation activities like the first multiplier event in Cyprus at 2022, one workshop. We have an operational website and social media accounts, the project logo, and also we have published till now 2 journal papers in respectful journals and 4 conference paper in accredited international conferences. Our planning till the end of this month is to finalize the second formative evaluation. Now, some open issues, and with this I will finish my presentation. Project result 1 should produce the final set of specifications and conceptual design. We have in front of us another version of our tools that will enrich all the functionalities and add new ones. Project result 3 will conduct at the end of the project a summative evaluation. Project result 4 should enhance course and training material. And finally, project result 5 will implement 2 sets of webinars in order to enrich the training material of our project. Well, thank you very much for your patience.
Thank you very much, Prof. Gougopoulos, for the insightful presentation and overview about our project. Any questions for coordinator? Bye-bye. So hi again, welcome back. So in this session, we are going to start with Dr. Stella Sileo from the University of Patras, who is going to talk about the first project result of the project related to the requirements verification and conceptual design of the framework for virtual exhibitions. Hello. Stella, the floor is yours. Thank you.
Thank you. Hello, everybody. Thank you, Marios, for organizing this event. My presentation is about the first project result of CREAMS project that concerns the requirements verification and conceptual design of the framework for virtual exhibitions. Concerning the role of the first intellectual output, its role is to verify and validate the results from the literature review through real-world case studies, to define quantitative and qualitative metrics for user acceptability, to set the specification of the CREAMS platform, and to design the conceptual and methodological framework of the CREAMS platform. This is the structure of the deliverable, the research methodology, the needs validation, the readiness metrics, and at the end, it analyzes the CREAMS framework conceptual design. These are the research methodology milestones. After literature review, we have selected experts' opinions. Our findings were triangulated concerning system designs, implemented applications, and best practices with the help of a group of art teachers. We have created series of mock-ups aiming to visualize services and functionality that were based on our findings and based on the literature review and the experts' opinions. We have created mock-ups, and then with the help of focus groups, namely focus groups of art students, of art teachers, and art exhibition visitors, we have evaluated the basic usage scenario of the CREAMS framework concerning the insights into their needs, into their preferences, their priorities. We involved 9 participants and 2 facilitators on average for each focus group, and the discussion session lasted about an hour. Then the 3 focus groups were led in each case by one of the 3 schools of fine and applied arts involved in CREAMS, the Norwegian University of Science and Technology, the Aristotle University of Thessaloniki, and the Shankar College of Engineering, Design and Art, with the presence of facilitators from the other 2. After that, we have defined quantitative and qualitative metrics that reflected the readiness of the universities to employ ICT platforms, and based on the state-of-the-art literature analysis, identification, and definition of quantitative and qualitative metrics used, we have, let's say, defined the conceptual design and its specification. You can have a quick look on the questionnaires that will be analyzed more in the presentation of Panagiotis Dafiotis later on in our meeting. And the workflow for needs analysis and verification was in 2 steps. In the first step, we have the mapping of existing approaches, requirements, and special characteristics of the material to be communicated through virtual exhibitions. And in the second step, we have the verification of findings of the needs analysis through semi-structured interviews with various stakeholders, based on, firstly, the formative user evaluation study that tested the effectiveness from the perspective of system integrity, let's say the technological approach, and the aptitude for exhibiting artistic material, the art specialist's perspective, and on art education and its potential for meaningful engagement through art that leads to learning, and secondly, the discussions among the consortium members and the discussion with stakeholders from various universities. We have revised the CREAMS conceptual design. For the digitization of the 2-dimensional and the 3-dimensional objects, artworks, it was necessary to carry out a literature review and find out all the technologies available at the moment. There are various measurement methods that could be applied for 2D and 3D geometric recording, and range, as we can see, from simple topometric methods to complex methods that use modern photogrammetry and surveying techniques for controlled surveys, and concerning the survey in XR technologies, we have, let's say, we have found and analyzed the basic technologies for XR, as we can see from this from the figure in the screen. We have made a survey concerning the personalization and its classification and how we can use the personalization in our case in virtual art exhibitions. We have also taken into account the personalization techniques that are mostly used: content-based filtering, traditional collaborative filtering, clustering-based approaches, association and sequence rule-based approaches, and hybrid techniques. And of course, we have found the XR systems for virtual exhibitions. All the results of our survey are published. For example, our survey concerning XR systems for virtual exhibitions has produced 2 publications in the first in 2 journals with impact factor. First one, it was a comparison of extended reality platforms and tools for viewing and exhibiting art, that has been published in the Digital Applications in Archaeology and Cultural Heritage Journal. And the second one was from Physical to Virtual Art Exhibitions and Beyond, surveying some issues for consideration for the metaverse, that has been published in the Journal of Cultural Heritage. These are the basic system functionalities to enable artists to employ 3D digital exhibitions, to develop tools that empower the artists to present contextual issues, ideas, and personal thoughts, to create multimodal in-depth descriptions of selected artworks, to permit the adaptability of modalities employed to the aesthetic and conceptual characters of the artworks, to permit the use of interactive features, digital narratives, virtual humans, and of course to provide the opportunity to art teachers to support art students and to assess their works. These are some screenshots from, let's say, how in our platform an art teacher can initiate an exhibition, how an art teacher can assess the exhibition, of course, each art teacher can assess various types of exhibitions, indoor, outdoor, VR, AR, etc. Of course, it can provide assessment with the help of other art teachers, with other evaluators. That's a screenshot from how a student can use a digitizer. The student can digitize 2D or 3D artworks. How a student can create an exhibition, You can see the opportunities that has for creating various art exhibitions, and how it can create and it can add an artwork and provide information about the title, the type of the artwork, the technique that he or she created the artwork, its height, etc. That's a screenshot from the platform, from CREAMS platform, that shows how an art student can set up an exhibition space, select the color of the walls, perhaps upload a narration or sound that the visitor can hear during its navigation to the exhibition, and various types of exhibitions from which the student can select for. That's how an art student can set up an outdoor exhibition. You can see the digital map area, the area that can add, he or she can add a description and various other features of the exhibition. And that's a screenshot of from our platform on how visitor can view the 3D exhibition. How the visitor can view an artwork and read about the description of the artwork, the title, the inspiration of the artist, perhaps have a look on the related works, related artworks, and of course hear the narrative that is connected to the artwork. Screenshot from with different views of an exhibition using the mobile application. The visitor, in our case, has the opportunity to display the closest gallery or display the closest artwork. Have a look on the digital map that provides a route that he or she can follow so as to visit the art exhibition. And screenshots from the augmented reality indoor exhibition, how a visitor can have a look on an augmented reality indoor exhibition. Some information about the readiness metrics. To construct the metrics, we identified, based on the literature review, of course, a list of criteria that are considered critical and essential to the construction of a digital exhibition making and learning platform. These operators are organized according to 4 axes that together form the basis of a successful virtual environment platform. The axis and its extremities are visualized in the figure, and the different levels are situated between the indicated extremities or liminal spaces. These extremities are not to be understood as metrically or conceptually opposed, but rather in context with the semantic operators indicate an importance measure for the applicability of the levels in our platform. So the core services of our platform are the authentication and registration of the user, the authorization, the administration issues, the geolocation services, the personalization services, the analytics, viewing and searching, and the copyright protection. The teaching staff services are mostly related with the exhibition initiation and the exhibition assessment, whereas the student services and are mainly related to the artwork management, the artwork digitization, the exhibition creation, and the exhibition management. Visitor services, they are targeted at students that use the framework in all stages of the exhibition procedure, and they will be connected with the social media sharing, the rating, etc. So some information about the personalization and the recommendations that are related to the topic. They are related to the art workshop, the exhibition assessment, and the exhibition viewing and relevant criteria. And also they can be related with the role of each user, the teacher, the student, the visitor, and what are these recommendations in what setting and when during the procedure. This is the revised system conceptual design. The framework consists of different layers of abstractions, the methods and procedures for digitizing information, for storing information, for retrieving data in different educational settings and scenarios, and of course, the open source tools. The system deals with the needs of art students, art teachers, teaching staff, artists, and visitors. It provides the ability for art students to personalize the narratives of virtual exhibitions based on specific user profiles and models. And it composes, the framework composes of several discrete modules that are grouped into two main categories: the front end, the exhibition and digitization technologies, and the back end. The back end takes care of most of the artwork content management. It hosts the required databases, security mechanisms, exhibition, teacher services like exhibition initiation services for the teachers, for example, artists services, and artwork management functionalities, and also the 3D rendering mechanism. The front end is about the dissemination and the digitization, and the system hosts several VR, AR, and MR applications for desktop and mobile devices. The system databases are the users, where we keep all the user-related data, the exhibitions, data about the exhibitions, the artworks, any data related to the uploaded to the platform artworks, and of course the knowledge repository, any data related to the produced tutorials, webinars, and courses. Well, the exhibition and digitization technologies module contains the VR main platform with the context management system and the web-based VR exhibition viewer, the AR exhibitions app, an AR exhibition smartphone application that will include augmentation of images using the camera and location, as well as QR-coded artworks that can be scanned. And of course, indoor and in-home scenarios, the native mixed reality application that uses HoloLens, and the digitizer smartphone application, and of course the social media integration and sharing. And finally, the user types, the different roles we have, the art school teaching staff, instructors, and educators in terms of acquiring in-depth knowledge of the most up-to-date media and application in the vast and expanding fields of digital applications, the art students, the visitors, the administrators, that people with technical expertise that are able to set up the framework within the various universities and research centers that will use our applications, and the artists that can create the art exhibitions. Our system will also host exhibitions by autonomous artists, graduates of the departments of the School of Fine Arts, etc., that can exhibit in the system freely without the need of assessment and evaluation from our teachers. So I think that's all. Thank you very much for your attention.
Thank you very much, Stella. Very nice presentation. Any questions from the audience? No questions, so we can move forward. Many thanks again, Stella, for your contribution and presentation.
Thank you very much.
This event. And we are going to continue on presenting the second project result of the project on the design and implementation of tools supporting digitization of physical artifacts and creation of virtual exhibitions. I'm going to give this presentation as part of Cognitive UX. Shared my screen. So in this talk, I'm going to give an overview on the second project result and giving the main objectives, tasks, leaders of this project result, and give an emphasis on the main outcomes of the latest version of our technologies, the high fidelity tools, which have been based on the conceptual design and the mock-up design that Stella Sideo just showed us. So project result 2 relates to the design and implementation of tools for supporting digitization of physical artifacts and the creation of virtual exhibitions. Lead organization is Cognitive UX GmbH, with all the CREAMS partners participating: University of Patras, Cyprus University of Technology, Aristotle University of Thessaloniki, Schenker Engineering, Design and Art, and the Norway Technical University of Technical University and Science of Technology, I think, and TNU. So I would like to give an overview of PR2 project. The main project objective relates to the design and development of an integrated platform for higher education institution scholars, aiming to create, disseminate, and promote digitally their research results by utilizing existing and novel solutions, by incorporating new technologies and ICT trends, So in this project, we aim to support an innovative workflow that consists first on the first part, digitizing physical artifacts into the CREAMS platform through a mobile application that has been implemented by the Cyprus University of Technology, assigning these digitized artifacts to virtual exhibitions through a web-based platform, and personalizing narratives through different technological means. And here we have implemented different technologies like a mixed reality application, augmented reality application, and virtual reality application to different target groups like instructors, students, artists, and visitors. The main objectives of this PR are first the design of a software architecture by realizing the conceptual framework that has been produced as part of project result 1 that was presented earlier. The second objective relates to the implementation, the main development of the technological tools, the methods for streamlining the digitization and further organization of visual, textual, multimodal material and data. Objective 3, implementing metrics and indicators for user acceptability, ease of use, sense of presence, and functionality of human-computer interfaces. And finally, the fourth objective relates to the implementation of a set of technologies, tools, open source tools and technologies aiming to personalize virtual exhibition narratives. So this was a quick overview about the PR. Based on the conceptual design that Stella Sileo has shown us earlier, we have implemented in the last 2 years 2 versions of the technologies. Following a user-centered design approach, we have implemented a low-fidelity version of the technologies in the first year. This has been evaluated as part of PR3, which relates to the evaluation of technologies. And based on the feedback that we have received last year, we have improved the technology and released the high-fidelity version, which I'm going to show you today. And this is currently being evaluated. We're currently at the end of evaluation. And now in the 3rd year, the final year, we are going to use the input from our evaluations and produce the final solution of the CREAMS project. The architectural design, as you can see, is based on let's say, classic client-server architecture. We have several client applications on the left side, starting with the Digitizer mobile app. As an Android application, we have the artist-centered content management system, which receives as input the digitized artworks from that have been digitized by the students. Then in the artist-centered content management system, we have embedded a virtual exhibition editor and viewer based on the A-Frame open source framework. And through this set of tools and workshop, the student can assign the digitized artworks in different mediums in virtual reality, pinpoint the artwork on a specific map or using geolocation services, then the AR mobile app, the augmented reality app, then shows these artifacts through the mobile application of the visitor, and the mixed reality native app, which has been implemented as a Microsoft HoloLens application. This illustrates the digitized artworks in a mixed reality context. The right side, we have the CREAMS server. We expose a series of application programming interfaces in which each of the client-side applications call in order to send and retrieve information about the content and media within the whole platform. And beyond that, we also use different other technologies, like for load balancing, we use Docker technology, and so on, to having in mind scalability and on how someone can build on this open source technology and scale this up. So a bit more information about the backend architecture. As I mentioned, we use a server-side web API based on Django REST framework, which is a toolkit for building web APIs. We use Nginx as a web server, reverse proxy and load balancer, Unicorn, which is an application server that implements the web server gateway interface, Celery for asynchronous task queuing, RabbitMQ, which serves as a message broker, PostgreSQL for the database, and everything is put under a Docker container. Now I'm going to give some more information about the CREAMS tools and technologies and the responsible partner. So Cognitive UX is the responsible partner to implement the artist-centered content management system, platform, and the integration of all the technologies. We have the web VR art exhibition for visitors and the native mixed reality app. The Cyprus University of Technology is responsible for implementing the Digitizer app for 2D and 3D digitization and rendering. And the Aristotle University of Thessaloniki, the LabGeo, is the main partner, responsible partner to implement the augmented reality mobile app, realizing the outdoor, indoor, and in-home exhibition scenario. So I will start with the artist-centered content management system, and I'm going to show you snapshots of the latest technology. And as I mentioned in my previous talk in the morning, all the technologies are running online. They are accessible through the CREAMS project website. Also, the source code is available through our GitHub repository. So anyone who's interested to further look at the code, further expand it, are free to do so. The key features of this application relates to instructor and student end users. So for the instructors, there are a set of instructor services which allow the instructor to initiate an exhibition, then as part of a project, for example, of a course, assign students to the exhibition, assign co-advisors that will co-assess, let's say, the exhibition of the students. And we have two main assessment approaches, a regular approach, the assessment approach in which the instructors assess the exhibition of each student after they submit their work. And we also implemented the curatorial approach, which is an interface, let's say, between the instructor and student before the students start working on their exercise, on their project, to exchange feedback about the reasoning of their work that they're planning to do, the students, and receive feedback from the instructors before they actually start implementing it. On the other hand, we have students that can manage their digitized artworks, the digitized artworks that either come from the Digitizer app or they can upload on their own their artworks. They can manage their media. They can create a VR exhibition through the workshop editor of this application. We have the AR exhibition editor. And we, of course, on the other hand, we have the curatorial approach, which is the other side of the interface for communicating between the student and instructor. And at the last point, we have also implemented a chat component, which is a, let's say, classic communication tool, enabling instructors and students to communicate at runtime through the platform for exchanging information. So these are some snapshots of the actual latest technology of the artist-centered content management system. So this is the instructor's dashboard through which they can access existing exhibitions that they started, and depending on the status of the exhibition, some might be temporarily stored, some might be accepting artworks, some might need to be assessed. They can quickly access these sections. An important task relates to an instructor initiating an exhibition in which they enter information about the title, the image of the exhibition, start date, end date, the space type, which can be either a modular space or a predefined space, for example, the Schenker gallery space. Then they assign students here. In the left part, we have student selections in which the instructor can assign specific students to that exhibition and assign co-advisors. Once this is done, the student, on the other hand, once they log into the system, they can create their exhibition that has been initiated by the instructor. So this goes on the next level. We go to the virtual reality workshop. So the student can then access this exhibition through, on the left side, you can see the virtual reality view based on the A-Frame open source framework, in which As you can see here, we see a simple room with 3 walls, ceiling, and floor. And the right part, you can see a set of tools which enable the student to assign the artworks that they have digitized and any other media like video, sound, and textual information, and assign it to this virtual reality room. And the main aim is to give the tools, a set of tools to the student to create a virtual exhibition as compared to a physical exhibition. Here you have a virtual exhibition. We want to provide tools to the student to create their own exhibition with their own digitized artworks and then disseminate it to their audience. Okay, of course, in this scenario, this is part of a project under an educational context, but these types of tools can also be used for dissemination, disseminating art of artists. This is a model of the Shenkar Gallery. So we have recreated a model of a real gallery from Shenkar with using tools from the editor. As you can see here, we have assigned a series of digitized artworks, 2-dimensional. We have used spotlights, ambient lighting, different colors on the walls to create. So each student can create their own exhibition by using this set of tools and be creative and create their own by themselves. This is another example of a sketchbook. So sketchbook is another concept that we have implemented. So the idea here is for a student to assign an artwork on a wall and then assign any associated material, media, like another artwork, textual information, video, sound, to that specific artwork in order to leverage on the concept of hypermedia, going beyond the media and providing more information about the associated material that relates to that specific artwork, which gives, I would say, an extra point, an advanced point for virtual exhibitions. This is something that someone could not do in a physical exhibition where the space is limited, more limited. Another example, again, through our tool, we have assigned artworks, titles, spotlights with different colors of spotlights. So everything was created by using the tool, the virtual reality tool. Now, with regards to the types of assessments, we have 2 main approaches, as I mentioned. The first approach relates to an instructor assessing the work and providing feedback after final submission of the student. And the second approach relates to the curatorial approach, in which instructors provide feedback on the selection of artworks and the reasoning of the student before they actually start implementing their exhibition. So here is a snapshot. Through the first approach, the instructor can assess a specific exhibition once they have that specific student has completed their exhibition, provide feedback on the VR exhibition, the AR exhibition, and so on. Now, the curatorial approach is a series of steps. As I mentioned, it's an interface between instructors and students in which the student first can select before they actually start implementing the exhibitions through the VR workshop that I showed you earlier. They select the artworks that they intend to use. They group it. They give a name on the name to the group. They can arrange the artworks in groups based on content, semantics, the colors, the material that they have used, the size, the formatting, and any other information. And then the instructor can provide feedback for improvements or to inform the student that they can proceed with this selection to start actually implementing their exhibition. So it's like an interface between students and instructors to communicate before the actual implementation of the exhibition will start. Moving on, I'm going to show the latest version of the augmented reality application that has been implemented by our colleagues from the Aristotle University of Thessaloniki. So the AR app is an Android smartphone app that enables visitors to interact with the students' digitized artifacts, now not in a virtual reality context, but in the context of a physical exhibition in which the artifact can be augmented either in a physical outdoor space using geolocation services, within indoor exhibitions by scanning a QR code, or within an in-home scenario by augmenting an artifact in the viewer's physical space. So the aim is to augment the physical space with the digitized artifacts in different contexts. As you can see here, on the left part, we can see a scenario, an outdoor scenario in which the visitor is nearby a specific artwork that has been pinpointed using geolocation services in a map. And once they are near that point, that location in the map, the specific artwork is augmented on the end user's mobile phone. We have the in-home scenario, which in which the no geolocation services are needed, but instead the end user, the visitor, is able to view the artifact within their home space, for example, by checking how a painting would look in the real wall of their house. And indoor augmentation is can be used for physical exhibition, indoor exhibitions, in which we can combine physical artifacts in a physical exhibition and printing a QR code next to the physical artifact, and then by scanning this QR code, the mobile application will augment and provide more information about that specific physical artifact. Moving on, the CREAMS Digitizer app is, let's say, one of the first apps that someone would use, a student would use, because through this digitizer application, the student is able to either scan, digitize a 2D artifact or a 3D artifact. So these are some snapshots. The student downloads this application. It's an Android app again, logs into the CREAMS platform, and then they are able to either digitize a 2D artifact or a 3D artifact. And so far, we have implemented a high fidelity version of a 2D scenario and an initial version, low fidelity version for the 3D artifact. Scanning, and the plan for the third year is to further improve and create a high fidelity version of the 3D scenario. So the cropping scenario, the 2D scenario relates to taking a snapshot of a 2D artifact. Once you take this snapshot, there is cropping functionality to crop any areas outside the boundaries of the artifact. Once you crop, you can upload it to the CREAMS platform, which is then available under the My Artworks of the student, so that these can be used for assigning them in a VR and AR exhibition. For the 3D capturing, we have an initial version which enables the end user to capture different sides of the 3D artifact, which is taking multiple pictures of a specific 3D object. And these pictures are then uploaded to the server, and there we have a script which tries to create a 3D model of these pictures. As I mentioned, this is still a work in progress. We have a low fidelity version. The plan is to further improve this so that a real 3D model is generated, and then this will then be assigned and integrated within the different types of exhibitions. And finally, we have a first version of our native mixed reality app, which has been implemented as a Microsoft HoloLens native application. So the idea here is to use the mixed reality context to augment and connect the physical with the virtual world and illustrate the digitized artworks and enable the end user to interact with these artworks within a mixed reality context. So far, we have implemented the main screens of this application. We have connected it with the main platform, with the APIs, and end users are able to interact with digital artifacts through a gallery view so far. So as you can see here, this is in a real context using the Microsoft HoloLens app. These images are retrieved from the CREAMS server based on digitizations or artworks that the student has uploaded, and then students can, the end user can interact, view, zoom into the specific artifact, see any associated material like a video, description of the material, images, and so on. And our plan for this year for the mixed reality is to further create more immersive experiences, enable the end user to connect through image recognition, a physical artifact with a digital artifact by taking a snapshot of the physical artifact, and then through image analysis, image comparison, illustrate and retrieve information that has been digitized to further augment it within the mixed reality context, as well as implement personalized narratives and interactions between the end user and the system. Some final remarks on our plans for the final version. Since this is a work in progress, we have implemented the high fidelity version of the system. In the past months, we have received very interesting and important feedback from proof of concept 2 participants and our partners. We have fixed runtime several issues. We have improved end user interactions based on the end user evaluations from the stakeholders from the participating universities. And we have gathered feedback for the planning of the final version of the CREAMS tools. And now the final cycle of development starts now in March until September 24, in which we aim to design and develop the final version of the CREAMS tools and technologies. And in September this year, we plan to release the final version that will be evaluated after September as part of the final end user evaluations of the project. These are some QR codes for the latest technologies. Everything can be found under the CREAMS project website. The interim version of technologies can be found under the second QR, and the ongoing version, because we are doing ongoing improvements to the technologies based on feedback that we receive, can be found under the third QR code. Thank you very much. This is what I had to say about project result 2 and the technologies that have been developed. Do you have any questions? Okay, so we can move on, and I would like to welcome Dr. Panagiotis Dafyodis from Aristotle University of Thessaloniki, who is going to talk about project result 3.
Thank you very much.
And on the system verification, user acceptance of the CREAMS framework. Panagiotis, the floor is yours.
Hello. Let me share my screen. Thank you very much. I'm going to provide a brief outline of the project result 3. It has to do with system verification. In fact, this has to do with the evaluation so far of the CREAMS applications. We provide, if you like, some feedback to the partners who develop the actual digital tools. This is the main role of PR3, to look into the methods employed in relation to how this assessment will take place. So firstly, before engaging in assessing or evaluating an extended reality application, we had to do some considerable desk research, identify and modify the methods to be employed, use these methods, gain results, and share them with partners in order to inform the development of the actual tools. This is an overview of the PR3, if you like, structure. It is split in 3 main tasks: to plan and design the evaluation methodology, to deliver the evaluation studies, initially formative phases, that is to say, stages that inform the actual development of the tools. And finally, have a summative evaluation. This is the task 3.3, and accordingly share findings with all partners. This is a visualization of what I have just been talking about. So now we are pretty much towards the end of task 3.2, which has to do with formative studies. And by the end of the project, in around a year's time, we will conclude with a summative study. Now, in terms of some actual planning, there is four separate categories of users, of participants in these assessments. I have to say that these assessments take place mostly on the basis of questionnaires, but also with the use of small focus groups where more open-ended discussions and qualitative data can be gathered. So this is, if you like, an overview of the four main categories of participants in correspondence with the four main applications that are currently evaluated. So you have a matrix of, roughly speaking, 15 different questionnaires. Questions obviously differentiate to a certain extent depending on whether the responder is an art student or an art lecturer or an ICT specialist. Nevertheless, there is some overlapping. We use a platform called the EU survey just to ensure the validity of the results. As you see lower on the screen, people will have to initially choose what is their actual profile, whether they are students or visitors, because in each application questionnaire, the questions will change depending on the responder's type, if you like. Very brief outline of the main methodologies that are currently used in assessing extended reality applications and experience. There is the so-called system usability scale, which is a 10-question set and fairly generic tool that mostly focuses on usability. UEQ, the user experience questionnaire, which has been introduced during the second formative phase, which is now towards its end, which is a fairly robust and versatile tool that has, if you like, a structure of a Likert scale with 7 steps. So people will just opt for the one or the other side of 2 opposites. They will say whether the whole experience is annoying or enjoyable, or they find the tool to be creative or dull. UEQ has another interesting feature. It distinguishes between pragmatic qualities, that is to say, usability issues mostly, and the so-called hedonic qualities, which are more, if you like, subjective, have to do with the degree of stimulation and engagement of users and the degree to which they perceive the whole application as innovative, creative, and so forth. So in an arts-related environment, you do want to have this aspect. Now, as I mentioned, it's a versatile and fairly useful tool because it has some benchmarks that are based on a large body of data and research that has been using this specific tool. So there is a critical mass of a 3-digit number of research instances that did use UEQ, and this is where these benchmarks come from. These are based on research by the developers of this approach. So these are not, if you like, arbitrary. We did focus on system integrity. This is to say usability issues and the relevance of what we have been developing with exhibiting artistic material, the aptitude, the appropriateness, if you like, of the platforms and applications given the specificity of the task at hand, and its potential to facilitate learning in tertiary art educational environments. From the first and also the second formative evaluation as input trickles in, we realized that there is a need for contextualization, that is to say, the ability of art students to add contextual material associated to their artworks, which is something that brilliantly has been developed with the partners working on PR2. Some people wish more realism. This is a moot point because realism is not necessarily a Hollywood-like hyper fidelity tool, but it has to do mostly with creating a space that is engaging and somehow does not distract from, if you like, the virtuality of the experience. And above all, there has been a continuous urge for guidance. So these are some themes, if you like, some lessons we have learned through the formative evaluation stages. So guidance could be in the form of error messages or more, if you like, easy to follow steps and environments that are more intuitive. We have used some case, if you like, some ready-made art exhibitions so that visitors could also have a say. Just a side note, but it's quite a central thing in our philosophy, is that an VR exhibition is not just the opportunity to replicate or create the shadow of the real thing, as it were, just to make, if you like, a digital twin of a real exhibition space. Digital virtual spaces do have an ability to be used as expressive means. So this is something we are taking on board as a potential. And some questions try to capture to what degree art students especially would like to exploit this expressive or creative aspect of setting up a space. There has been lots of feedback in terms of art students especially wishing to manipulate the spaces and be more creative with them. This is a recurring theme. I'm showing some additional snapshots from art exhibitions currently used for visitors evaluation. And a very quick snapshot in open question results. These are some indicative positive responses in terms of what people like the most. Some underline that artworks are already computerized in some instances, so this is a more appropriate, perhaps, environment to show artworks that are created by new media artists. This is an interesting aspect because we mostly think of physical artworks that are translated into the digital realm. People like the light effects. I can just go a couple of snapshots back just to showcase how important lighting is to add energy to the space. Because in the end of the day, it's not about, if you like, the illusion of reality, is about the degree to which you can create an engaging virtual space. Some negative, if you like, feedback aspects that people liked the least, some nagging about bugs and so forth, that has been to a certain extent addressed. Some misapprehensions, people who thought that editing, for example, of an exhibition after saving is not possible, which is not the case, which highlights the need for additional guidance. Improvements people would suggest. Actually, I had a discussion in a small focal group yesterday, and people complained, for example, about the fact that they would like to see more controls over video input, so they don't run on a loop or something like that. Now, just a further quick look. I'm keeping an eye on the time as well. These are some indicative results of how students receive the VR platform. So the most, if you like, negative aspect would be that there are some dependability issues. People feel that they are not sure what happens next, so they don't feel fairly comfortable. Nevertheless, stimulation is there. Perspicuity, which is the degree to which people can sort of connect to the system and understand how it works. But these are benchmarks that relate to a finished product. So we need to keep in mind that as we are, roughly speaking, halfway through the development process, this can be seen as, if not encouraging, as results that are within the range of promising. As I mentioned, this comes from the UEQ system. I'm not going to bore you with more statistics, except for switching to the system usability scale, which gave 65, roughly speaking, % of acceptance in terms of usability, which, bearing in mind that we talk about something which is half through the development process, is once again an encouraging result. Now, the role of other partners is obviously to provide participants questionnaires. At this point, I have to say that even people who can participate in the evening session at Mannheim may wish to fill some questionnaires that I have already forwarded to Mr. Bell. And we do have, apart from the VR platform, the other applications that come, if you like, with lower KPIs. That is to say, we have a need for a relatively smaller number of participants. But as these applications are mainly focused on art students, the main target group is exactly them, and the most, if you like, primary key application is regarded to be the VR platform, and the other ones are, if you like, more or less contributing to add an extra layer of possibilities opening up in the space and so forth. And this is reflected on the KPIs, which means the key indicators, the key performance indicators that are higher in the VR platform, which is the place to work on curatorial issues, on contextualizing things. And once you get the knack of this, you can perhaps exploit better the other applications. By that, I mean the mixed reality ones. As Dr. Belk said, Digitire is a tool that comes fairly early in the process, as it allows art students to upload things on the VR platform, which is the hinging point of the whole CREAMS project. So thank you very much for your attention. I hope I stayed within the stipulated 20 minutes.
Thank you very much, Panagiotis. Very nice presentation. Any questions from the audience?
Just wanted to reiterate that perhaps
Yes.
if there is a hands-on use of some of the tools during the evening session after lunch, there is also the opportunity for people to receive the links for the questionnaires and fill them either on site or following the participation. Thank you very much.
Yes, very good idea. Thank you, Vanioli. We will do
And
that.
I have forwarded the email to you. So
Yes, I received it. Thank you very much. We are going to do that. Yeah, good idea. Okay, thank you very much, Panagiotis. And according to the agenda, we will have a short coffee break. Moment. Okay, we are slightly ahead of time, but let's keep the schedule, I would suggest, and we will be back in about 11 minutes, 12:30 CT time, to continue with our next speakers. Thank you very much. So welcome back after the coffee break, and we're going to continue with our presentations. Would like to ask Ms. Kyriaki Georgiou from the Cyprus University of Technology in Cyprus to give us a presentation on project result 4 that relates to the course and training material development on virtual exhibitions for art students. Kyriaki, whenever you're ready, we can start. Thank you. Can anyone see the shared screen? Yeah, I can see it now.
Yes, I had a minor problem. It's everything okay?
It's sharing, but it's in dual mode view. Now we can see the main screen. Yeah.
One moment. Now it's okay.
And it's again both slide view and notes view when you click on presentation.
One moment.
Mm-hmm.
Now?
Perfect. Now we can see your main screen.
Yes. So hello everyone. One moment. Now I'm ready. Hello everyone. My name is Kyriaki Georgiou, and today I am representing Cyprus University of Technology on behalf also for Mr. Marinos Ioannidis. And we are in the context of the leaders of project results 4 of the CREAMS project, which aims to develop course and training material for virtual exhibitions for art students. Now, let's have an overview of project results 4. In general, project results 4 aims to develop course and training material for art students about virtual exhibitions. This training and course material encompasses practical design implementation and integrational guidelines concerning virtual exhibition technology of the CREAMS. Now, the content of Project Results 4 highlights the conceptual and practical aspects of virtual exhibitions for our students, the insights on presenting, teaching, and training methods and techniques within the higher education and institutions, and also hands-on tutorials focusing on the design, implementation, and setup of virtual exhibitions for our students. Now, the Project Result 4 has as target audience students, researchers, practitioners in visual arts, trainers and instructors of higher education and institutions, software engineers, and the result type of PR4 is learning, teaching, training material, and manual material. The Project Result 4 has three main objectives. First, to develop course material for instructors and students focusing on theoretical understanding and practical application of extended reality technologies in the arts domain. Second, to create best practice guides and training materials tailored to various scenarios in virtual exhibition creation. And third, to provide instructions and tools to ICT specialists and software engineers for installing and maintaining the technological infrastructure of the CREAMS platform. Also, the Project Results 4 has three main elements of innovation. The first innovation that focus on is the lack of coherent platform, meaning that no existing platform integrates state-of-the-art tools and training methodologies for our students. Secondly, to create novel educational material with input from needs verification analysis, specifically results 1 and validation and evaluation studies from results 3. Those will contribute to the educational and training material development. And third, the Project Results 4 aims to bridge the gap by providing a comprehensive platform for art students and higher educational institutions. Now, as soon as the results of PR4 will be finalized, CREAMS project will create for all the materials multilingual documents translated into English, Greek, German, and Hebrew, and Norwegian, and also will have its own online knowledge repository accessible through the project's website and will include the developed material there. Now, Project Results 4 consists of three main tasks to achieve. First, task 4.1 is the course material, and then task 4.2 is the guides for best practices and training material for instructors. And task 4.3 is the development of material for ICT specialists and software engineers. Now let's have a deeper look on what we will be developed through the Project Result 4 and the different tasks. In task 4.1, the course material for a course titled Introduction to Virtual Environments and Virtual Exhibition is developed. Secondly, the 3 video tutorials, each one dedicated to the different application and platform. 3 user manuals also is developed, which each one will be dedicated to a different application platform. And 2 PowerPoints for the instructors to use for the course created from the course material is where I'm going to be also developed. And in task 4.2, the best practice guide for planning and executing successful virtual exhibition is developed. And training material for instructors based on the course material developed from task 4.1 is developed also. And in task 4.3, a guide for software engineers will also be developed based on the applications and the platform. Now, for the task 4.1, We will have an in-depth look of the part of the course material and the 2 PowerPoint presentations from the instructors to use for the course created. And then in the next slides, we will continue with the second part of the task 4.1. Now let's focus on what is the aim of task 4.1. The main objective of the course material in general is to offer guidance on effective utilization of CREAMS tools for academic and artistic purposes, to enhance student engagement with hands-on experience of the CREAMS tools, to foster critical thinking and creativity in designing virtual exhibitions, and to facilitate also collaboration among students in creating virtual exhibitions. Now, the key features of the course material is, firstly, the material follows a traditional university course syllabus format. Also, various assessment methods are outlined to evaluate student learning and engagement. Also, a 14-week curriculum is added to the course material, which is divided into thematic units. And lastly, clear learning outcomes are defined for each module, ensuring this way alignment with course objectives and student expectations. Now let's take a look at the course material content. First of all, in the beginning of the document, we have the aim of the course. Then we have the learning outcomes of the course that outlines the learning outcomes that a student will have from this course. Then all the important information regarding the course, prerequisite background, suggested bibliography, course assessment, everything that a student and an instructor must know and follow for the course. Now the next section is options for evaluation steps from the instructor regarding the course assessment. This section includes multiple assessment methods for an instructor to choose in order to evaluate students. And now this next section is the 14-week structured curriculum. This addition is a clear and organized framework for the course, enhancing and learning the journey for both instructors and students of the course. And as you can see in the course material, we have incorporated a table representing the breakdown of topics covered each week, along with the corresponding module numbers and titles. The last section is a basic content of each module of the 14-week structure we saw before. And now regarding the creation of 2 example presentations that instructors can use in a lesson environment, 2 modules have been informally selected from the 14-week structure, so it will be more clear and more in target the presentations. The module number 1, overview of virtual exhibition, and module number 2, understanding user experience in virtual environments, are selected to create PowerPoints from the instructors. The first presentation for module number 1 will focus mainly on topics such as introduction to virtual exhibitions, historical context and evolution, benefits and challenges, and different case studies that overview the module at the end of the module. The second presentation for module number 2 will focus on topics such as introduction to user experience design, principles of user-centered design, cognitive psychology, and everything that aims to that module and an instructor can use for the content of the module. Now let's have a deeper look of the second part of the developed outcomes of task 4.1, the 3 video tutorials and the 3 user manuals. Now, user manuals and video tutorials were made to provide detailed support with written instructions and tips for utilizing each software that were developed in the CREAMS. and also will empower comprehensive support for users to create and manage successful virtual exhibitions. Now, the primary aim of user manuals in CREAMS is to concise introduction to application or software, provide guidance on manual organization for easy referencing, and give details on hardware and software prerequisites for each platform and application. Moreover, straightforward instructions on downloading and accessing the application, user privileges and functionalities, and in-depth exploration of features throughout the platform and the applications are demonstrating also. For the CREAMS project, we currently have developed 3 different user manuals, one for the CREAMS platform, one for the AR application, and one for the digitizer. The manual developed for the CREAMS platform is a comprehensive manual covering all functionalities for the developed platform. For the AR application, the manual addresses installation requirements, obstacles, and errors someone might face throughout the use of the application, and in general enables users for a full and liberal operation. Now, for the digitizer, the manual covers digitization methods, metadata, and preservation, and also ensures full and liberal application operation also. All 3 user manuals consist of 4 main parts: general information, system summary, how to download and access the application or software, and users' privileges. Now also we develop video tutorials, one for CREAMS platform, one for the AR application, and one for the digitizer. Basically, there are many video tutorials showcasing each step that the user might need to follow in order to download and in order to provide a visual guide complementing the written content of the manuals. All the aforementioned course material and user manuals will be developed also in 5 languages: English, Greek, German, Hebrew, and Norwegian, in order to ensure accessibility and eliminate language barriers in the learning process. And now for the task 4.2, guides of best practices and training material for instructors, 2 outcomes will be delivered. First, a guide of best practices, that is to provide best practices for planning and executing successful virtual exhibitions, and also a training material for instructors, which is in the development stage, and in general is to provide best practices for delivering the course developed for the CREAMS tools that we were referring before. Now, the guide of best practices was to develop in order to provide best practices for planning and executing successful virtual exhibitions. And with the best practice guide, we are illuminating novel opportunities for our students, teachers, and professionals through the innovative technology and CREAMS tools. For students and instructors, this guide is showcasing work in novel and exciting ways, can connect with a broader audience and garnering valuable feedback and exposure. And also someone will gain practical insights for students, constructing portfolios, and instructors orchestrating for virtual showcases. Now, the second outcome, as we mentioned before, of task 4.2 is the training material for instructor. This document basically empowers instructors in delivering the course we mentioned in the course material, Introduction to Virtual Environments and Virtual Exhibitions. Now, the main key components in this training material is designed to serve as a comprehensive guide for instructors. Also, it provides valuable insights, strategies, and examples to facilitate effective course delivery. And also, the material emphasizes the integration of innovative CREAMS technologies into the teaching process of an instructor. Now, the training material for instructor consists of 3 sections. Section first is the introduction to course delivery, which outlines the course objectives, target audience, emphasizing the importance of effective course delivery. Section 2 is the strategies for successful course delivery, which includes key considerations for creating a successful learning environment for the students. And at section 3, lesson structure and examples, which explores fundamental components of effective lesson structure for the modules outlined in the course material. Now, an important section in the training material is called material content for each module. This section basically outlines a structured approach for each module of the 14-week curriculum course and how to integrate CREAMS technologies to each module. For each module in the training material, as you can see also through the first module, in the picture is the module number and title, the module's objective, the module's content, which is significant parts to cover in each module by the instructor. Now, to each module is outlined an activity part, which is an interactive activity for students related to the module. And in the end, for each module is outlined the technology integration, explaining to instructors how CREAMS technologies can be incorporated into the module. Now, the task 4.3, material for ICT specialists and software engineers, aims to provide comprehensive instructions and methodological tools for software developers and specialists. So the expected outcome that we are working on is the development of an integration guide showcasing the main aspects for the 3 tools that the software engineer needs in order to integrate the CREAMS platform and the applications. So this integration guide will include detailed instructions tailored for software developers and ICT specialists, and facilitate a smooth installation, integration, and operation of the platform's components, and an essential troubleshooting for the platform that someone might need. Now, in conclusion, the development of course and training material for virtual exhibitions in the context of CREAMS project represents a significant milestone in enhancing the creative potential and technical skills of our students, professionals, and educators. Through comprehensive framework, toolchain, and educational resources, we have aimed to scaffold the creativity of our students and empower them to create their own virtual exhibitions. And overall, the project fosters critical thinking, creativity, and collaboration among students, while also promoting the adoption of innovating technologies in the field of visual arts. Thank you for your attention.
Thank you very much, Kyriaki, for the very nice presentation and overview of PR4. Any questions from the audience? Okay, very good. No questions. We can move forward with Dr. Rebecca Vidal from Shenkar College of Engineering, Design and Art in Israel, who is going to talk about project result 5 on the development of webinars for training the trainers on virtual exhibitions for art students. Hello, Rebecca. Nice to see you.
Hello, everybody. Thank you, Maria. I'm going to share my screen. Okay, so Shankar is responsible for creating the webinars, for training the trainers on virtual exhibitions for art students. We have already organized 2 webinars out of 6, which are part of our intellectual output, our project results in group number 5. The 2 webinars were organized last May. We had 110 registered participants in both webinars. One webinar was from the student, for the students, and one was for lecturers, where we also talked about the curating process in the virtual realm. And we showed a hands-on demonstration on the proof of concept number 1, which was ready at the time. You see here the distribution of participation of the universities. And we had, of course, a larger participation for students, and then a little bit less if we look at the 2 webinars for instructors. So we had more registered at the end of the day. In the student webinar, we had 78 participants, and in the faculty and lecturer webinar, we had 43 participants. What we are planning now is in this May to have another webinar for students again and for lecturers. As our platform has advanced to proof of concept 2, we will have most of our session on a hands-on practice in creating VR or AR exhibitions. And then the 2 last webinars are scheduled for November and December 2024. The November one is for software engineers, so it will touch the more technical aspects of how to make changes or add to the platform. And in December, we will have a webinar which will be open to everyone. We are holding all the learning material on our Moodle platform, which will be open for during all the time of the project and an additional year after that. You can see here our Moodle. You can access the website and the proof of concept 2. You can access the platform from the Moodle. We have the course description, which is in 5 languages: Greek, English, Hebrew, Norwegian, and German. The online session links also appear from here. You see the past links, which at this point are hidden from the users. Only lecturers can access them. But then when we have the new links for May, it will be here. We have the CREAMS platform evaluation questionnaire here. We have the student link and the instructor link. The different user manuals that our partners from Cyprus have developed in the different languages. All the partners contributed here for the translation of the manuals into the different languages of the partners. And this is the latest material that Cyprus University has produced, the course modules and instructions for lecturers to build up XR exhibition course. And we have dedicated a section to that, which we can add. Right now, there are still drafts, but we can add and place the training material for the lecturers here. And we have the video tutorial for the different parts of the platform and the digitizer and the mobile app, as well as the recorded meetings. We have here 2 recordings of the webinars of last year. We had some special sessions for our students in the curatorial studies. So we've placed the recordings here. They're actually in Hebrew, the 2 recordings from our students. And the link to the CREAMS Moodle is here on the screen, but it's also accessible from the CREAMS website. We have contributed with our knowledge in Shankar on curatorial studies and on the curatorial process. We have worked with cognitive UX to develop, to allow for the platform to accommodate the curatorial process and the curatorial thinking with the different stages of work that a lecturer usually goes through with the students, even before he goes into 3-dimensional space, on the way of thinking about art, categorizing the art pieces and building up the narrative, because we feel that our platform has this added value rather than other platforms that allow for online exhibition. It has this added value of accommodating the curatorial process. We have integrated the CREAMS platform in 4 courses last year, and we are currently also integrating it in 3 more courses this year. Part of the students of these courses go into the platform and work in virtual space. And here is a paper that I have initiated together with partners from the CREAMS team that we've published on the comparison of extended reality platforms and tools for viewing and exhibiting art. Thank you. I would like to also make a small demonstration of some projects that our students have done in Shankar within the platform. So this is a design student that has created a virtual gallery of her portfolio of work, of design work. The space, the gallery is divided into 3 spaces. She's using the modular option for creating a gallery. And you can see here, she has her first section is architecture, then it's design projects, and the last is art projects. We can see the capabilities of the platform. Several works have been displayed, lighting has been applied, use of text. Also, the student used the tool of metadata, which opens up. We can see some bugs here still, that some of the metadata comes blank, but it has this possibility. And an additional project. This is from our interior building and design environment student. And we have also a project from a student of the curatorial studies. The student here chose the Shankar gallery that has been modeled and is one of the options in the CREAMS platform. You can choose to create your own modular gallery, or you can get a ready gallery that's already available for the platform. And here we see one of the galleries we have in Shankar, which was accurately modeled. And she's displaying an exhibition of artificial intelligent created mushroom exhibition. We can see some features like spreading the art pieces over the wall and connecting it with continuously with the next wall, even turning around the corner, playing with colors within the space and with the text. Thank you. Any questions?
Thank you very much, Rebecca. Very nice presentation, very nice works from your students. Any questions from the audience?
Just a quick one. I noticed in the Moodle there is, which is so excellently structured and presented. There are two links for questionnaires. I think it could be a good idea to update them and use the links I have sent for the VR platform fairly recently. So this is just a side note.
Panayotis, this is you checked on the link. It doesn't lead to your latest questionnaire. They lead to a previous questionnaire.
Yes, I think this is a Google form format. So this is a version that was perhaps added to the Moodle prior to the links I have sent out on the 31st of December, if I remember.
If you can forward to me
sure,
both
absolutely.
links again on the email, I'll make sure that we are updated with the latest links.
Okay, thank you very much.
Replace them.
Any further questions, comments from the audience? Okay, thank you very much, Rebecca, for your presentation and contribution to the event. And we have another one last presentation from Mr. Martinus Suikerbuik from the Norwegian University of Science and Technology, Norway, which starts in some minutes. Don't know, Martinus, is Martinus here? Okay, let's wait some more minutes. Let's use it as a short break until Martinus joins, because it starts in some minutes, and I will we'll let you know how we proceed. So let's have a short break. So hello again, I am back. I've been informed that unfortunately for some unforeseen reason, we'll not have the presentation from NTNU. So with this, we are going to end the online session for today. I think this was a successful event, successful session. Many thanks to all the presenters for your contributions to the multiplier event of CREAMS. We are going to have a lunch break now, and after the lunch break, we are going to have the in-person session here at the University of Mannheim, in which we have some invited guests, and students will come to see and interact with the implemented technologies here at the university. But this will not be online, it's only for in-person participants, though, so the online session will end now. Any remarks, any comments before we close our event?
Well, Marius, I think that it was a successful session. Thank you very much for the organization. I wish the next session to be as successful as this one. Thank you very much.
Thank you very much, everyone, again, for your contributions and the very nice presentations. And to all our participants, for attending our event. Thank
Thank you
you.
very much.
Bye-bye.
Bye.